Hi there. Very welcome to this super exciting session. I'm Erik Schön. I'm your track host, heading up Airlink Solutions in the Nordics. So it's a great pleasure to welcome Ju Liu, originally from China, been doing pasta in Italy and computers in London and rock climbing and whatnot. But now I think this will be the highlight of today because it's live coding. We all love live coding, right? And this is the classic video game of Pong in the Scenic library by Boyd Malter. So this will be such an awesome session, I'm sure. And yeah, if you have questions, please type them into the Hoover app as we go along, and then we take them afterwards. Without further ado, please take it away.
Thank you so much, Eric. Cool. Let me know if you can't hear me or if I'm too loud or anything like that. I'll try to adjust myself. I don't think we need to introduce Pong as a game. I think, it's probably, maybe this is like the start of a really fiery argument, but it's probably one of the most well-known video games in the world. So let's just like start doing something. I just prepared like just a little bit of work, but nothing too exciting. So, oh no, for some reason okay, hopefully this won't steal my focus anymore. But basically I just created a small repo. Oh no, every time I type, I don't know why, but the app is stealing my, well, okay, let's hope like this is the last time the Zoom, oh no, you see every time Zoom ends, like it steals my focus. So this is a bit weird. How do I hide floating meeting controls? Okay, hopefully this is it. But basically, I've created this small folder. It has like some Nix configuration. If you've never heard of Nix, it's basically a dependency manager. So usually I feel I'm struggling when I'm trying to install something because I don't really know which are all the packages that need to be installed in the system. So Nix is a very nice answer for that. I'm just going to quickly show you what I'm saying. So basically, everything that we need for our project. Okay, let me just rename this to Scenic Pong. You see, like these are all the dependencies this project needs. So for example, you can see that this is Elixir, there's some OpenGL libraries, and there's like the Cocoa framework for macOS. But basically, this is everything that the app needs. I'm going to try to, I don't know why, but the Zoom app is continuously stealing the focus from my terminal, which is really annoying. I'm not sure if there's some way I can disable that. Preferences. No, share screen. Yeah, I don't know. I'm just gonna pretend like nothing is happening. But once you have that, you can create scenic.new in the current folder, and it will install all the dependencies. So for example, if I do mix-steps get, you'll see like it installs everything, and then I can run mix scenic run, and this will compile everything and start this OpenGL application. I think I haven't really explained like what Scenic is, but it's basically a framework for building UIs in Elixir. So I don't think that it's really designed to build video games, but like we're in the era of computers, so we can pretty much make the machine do whatever we want. Okay, so you can see that here we're on the starter app, and I'm just going to quickly show you how that works. So we have a config file, and the config file has a default scene. So this is like the pointer to where the application will start. And we're just going to change that to make it point to another scene. But I just wanted to quickly show like what is like the default home. The default home is this Elixir module, has this init function. You don't have to worry about most of this stuff, but basically the great part about, like the most important part about this is that there is a graph, and we add things to this graph, and then we push the graph. And by pushing the graph is how we actually render the graph. and push it to the OpenGL container. So what I'm going to do instead is just to copy this whole thing and create a new game X, paste this whole thing in, and replace home with game. I'm going to remove all these comments because who has ever read comments? Okay, let me get rid of that. Okay, that's good. And I'm also going to get rid of this and get rid of this. I'm getting rid basically of everything. Actually, we don't even need the fonts. So I'm just going to create this build, like create this graph. And just to get things started, I'm going to create a small rectangle. And this rectangle is going to be 100 pixels inside. I'm going to fill it with white, and I'm going to give it an ID. And I'm going to call it ball. Yeah, so you can see like this is like the absolute bare bones. We don't need this. I've hooked up the Elixir language servers protocol. So it should help me a little bit when I'm live coding to not make a complete fool of myself. So now if I run this using mix sync run, I will be able to see this. You see, we have our square. And this is our square. It's filled with white, and it's called ball. This is like I've written 30 lines of code and already made something which I think is a bit of a mistake, which is to create the graph at runtime. So if you read a bit more through the Scenic documentation, you will see that it's very much recommended to build the graph at compile time, because in this way you will have it type checked basically. And it also, like from a performance perspective, it is more efficient to create these things at compile time. So I'm going to do that. I'm going to just move this to a variable. So I'm going to call it ball. But the problem is, like, usually then if I just put this rectangle here, I can't really do much with it, right? Like usually, especially if you're building a game, you really want to move things around the screen. So in order to do that, I'm going to use the API of Scenic. And there's a function which is called graph modify. So I'm going to pass the existing graph at graph, a pipe here. And this modify, first of all, it requires an DID of something. So I'm just going to say ball. And then basically you have some ways to change the existing element. So we're going to use a function which is called update opts, which is a function that just changes the options. So it doesn't change the data of like what we're trying to display. So it's not going to change neither the shape of the image, but it's just going to change some of the options. So in order to do that, I'm just going to say translate, and then I'm going to say 200, 200, yeah, and do that. I'm also going to just create a state because it's always nice to have it like explicit, yeah. So graph, new graph, and here I'm going to pass the state. And you'll see like this is very similar to how a Gen server operates. You just like need to pass this third argument in the tuple, which says, when to push this graph. Cool. So now if I run this, we should be able to see our square. You see, we've just moved it. So you see, like the graph was initialized at compile time, but then at runtime, we were able to modify it and change it. And this is basically the same technique that we're going to use to move it around, right? So I hope that's clear. I'm not reading the questions right now, so I'm going to answer the questions at the end of the presentation. I hope that's cool. Okay, so one thing I would like to try to do is to move this ball to the center of the screen, right? So I've commented out like this line before, but I'm going to uncomment this. And I'm just going to rename this to indicate there the viewport width and the viewport height. And then I'm going to say, I'm going to calculate what is the center of the screen, right? So in order to calculate the center of the screen, I'm just going to take the width and subtract to how big the ball is. But right now, all these things are constants, and I don't like that. So I'd rather have these be numbers. So I'm just going to say that this is both sides, and I'm going to replace this with both sides and do the same here. Cool. And here, basically, to calculate the perfect center, we can do this. And for the y, we can do the same thing, just replace it with the height of the viewport. And here in the end, I can just say ball x, ball y. Perfect. Okay, cool. So it's a bit smaller because this is more like the original game, but I have successfully put like this little ball at the center of the screen. This is not much fun because the ball is not moving, and I can hardly imagine playing Pong with a ball that's just like static, right? So usually, if you like, this is like one of the simplest games in the world, but still like there's like this idea of having a sort of timer that's continuously changing the state of the world, and then we're doing something to render it and to display it, right? And since we're using Erlang and Elixir, it's like one of the best use cases for this. Like we can create timers like in thousands of ways. What I'm going to do is just to create a very simple timer. I'm going to say, okay, I'm not going to save the timer, but I'm going to use this Erlang library called timer. You can do send interval. You have to pass some milliseconds and send a message. So I'm just going to say that animate ms. And in this case, I'm going to do something slightly weird. So I'm going to use trunk to get an integer. And I'm going to say 1,000 divided by 30. And this is because this is in milliseconds, and I would like to have almost like 30 frames per second. So it's just like a little trick. You don't have to do this, but I think it's just like a nice little thing to get like a fluid animation. And basically now every, I don't know, probably X number of milliseconds, Elixir will send this message. So we can just handle it like you do normally in a Gen server. You can just do handle info, and you can say animate and get a state. And here, basically, what we want to do is we want to grab the position of the ball. So I'm just going to say xy equal graph get, and this will get something from the graph. So in this case, we can just do state graph. We can pass the ID, and we can grab the transforms translate. Okay, cool. So this is exactly where that image is right now. And I guess at this time, probably it's nice to store somewhere in our state the speed. So I'm going to store the speed as a vector. And I mean, it sounds complicated, but it's actually just two numbers, right? So I'm just going to say that the velocity is going to be 2, 2, then I have some random numbers. And here I'm going to say that I'm going to extract these two components of the velocity and just do state.vel. And in this way, I then can calculate the new x and the new y, right? So, and in order to do that, I can just grab this and sum the vel x, y, sum the vel y. And in this way, you see, like it's basically we made a tick, right? Like we made one little change in the state of the world, and we're going to reflect that onto the view. So in order to do that, we can just do the same thing we did before. I'm going to say a new graph. I'm going to take the state graph and use the same thing I did before. So this block, I'm just going to copy paste it actually. But instead of ball x and ball y, now I have new x and new y. And maybe just for fun, I'm going to inspect these numbers so we can see something in the console. Yeah, so something that I forgot to do is I want to do no reply, and I want to update the state with a new graph, right? So I'm going to graph new graph. And here I'm going to push the graph again. Otherwise, your change won't be reflected in the UI. Hopefully, I haven't made huge mistakes. I think something is complaining because this is trunk, and this is why the language server is so cool. Now, if we run this, we'll see, oh, our ball is moving, except that when it hits the borders, it fades into nothingness and is lost forever. It's basically the astronaut, which has, lost contact from the mothership. So clearly that's not good because we've lost the ball, and it's like, wandering into nothingness. So we want to do something about that. And in order to do that, we have to think like what's happening. So like we are continuously moving this ball around. At some point, the ball just falls off from the borders of the world, right? So what we want to do instead is that when that happens, we want the wall, like the ball, to bounce back, right? And since we have this velocity structured as a vector, there's a very easy way. So if we realize that we are hitting one of the borders, we can just negate that axis, and that will make the ball immediately fall back. So basically here I can just say new velocity x, and if the new x is less than 0, or the new x is greater than, I don't think I've saved those heights, so I'm just going to do that. VP height, VP height, VP width. You can always grab this again from the viewport, but I think it's just nicer to have all the variables that we need inside the state. So here I'm going to say width do negated velocity of x, else vel x. And I'm going to do the same thing for the y. Just going to grab all this, replace all the x with y. Yeah, and I think also this should be a VP height. This should be VP width. Okay, so we've calculated these new velocities, but we haven't really updated the model. So I'm going to do that. I'm going to say that the new velocity is just new vel x, new vel y. Yeah. Perfect. Well, I know like when the Elixir formatter triggers, it means like I haven't made 2 awful mistakes. So if we run this, you'll see that it's better, but it's still like a little bit weird. Like I don't know if you noticed, but the ball like went like a bit over and sort of almost like went out and then bounced back, right? And the reason why that happens is because like we're, like I feel like every time you're building a game, you're sort of like building this this structure of lies upon lies upon lies. You're sort of like a politician, and there's nothing's real. Like, oh, everything is fake, but still, like you get to a point where there's so many lies piled up together that, like for the person who's playing the game, like it feels real. So our current problem is that we're checking this against the total height, but we haven't considered the size of the ball. So in our case, we actually want to do minus ball size. And if I subtract now the ball size, you'll see that now it looks good. But as I said before, like nothing is real. Like every time like you're writing the game, like you realize that there's a lot of like lies involved in building a game. Cool. So I don't have a lot of time left. So I think this is pretty cool. I'm just going to spend like a few more minutes, maybe 10 more minutes trying to build as much as I can. And then I'm going to show you like a more like feature complete version of the game, which I think is quite cool. So in the time that we have left, maybe we can just try to add the paddles. And it's basically the same way, like just as we've animated this ball, we can add the paddles. So I can just say, maybe I can say something, paddle width is going to be the same as the, actually, let me do this, because I don't like the fact that the paddle depends on the size of the ball. I know, I have no CD or something. Tile size, and then we can say paddle height, and this will be tile size, let's say multiplied by 5. So we have like a small paddle, and here we can say that we will just add this, and we'll say that this is the paddle width, and this is the paddle height, and we can just fill it in exactly the same way. I'm going to give it an ID, and I'm going to say that this is the left paddle, and I'm going to copy this and call it right paddle. Oh, no, Zoom stole my focus again for some reason. Anyways, I hope you can see. Oh, maybe I can also fix the formatter. I'm always annoyed that the formatter doesn't do like a proper line length. I think I can just do like 80 here. And hopefully now when I open the game again and I save, yeah, that's much nicer. Awesome. So we have everything and we do all this and this is cool. So now we have these paddles, but if I start the game now, you'll see like where the paddles are. They're both here on the top left. This is not very useful. So we actually want to move these paddles somewhere else. So just like I did for the ball, I'm going to do the same for the paddle. So I'm going to just do paddle Y is paddle height. And I'm going to do the same thing here. And here I'm going to change left paddle. And the left paddle is going to start as the screen starts, and is going to be paddle Y. And here I'm going to grab the VP width. I'm going to subtract the width of the paddle width. And this is paddle Y. This should be right paddle. Cool. So if I start it now, we should be able to see the paddles properly centered. And you can see like they're nice there. And something I want to show you is like, if I press some keys, we can see in the output that the app right now, it's wired in to log them out. It says received event key W, right? And this is all controlled by this special callback called handle input, which is basically listening to a lot of stuff like clicks and keystrokes and everything. So basically, if I wanted a way to control that, I could just say handle input. I can pattern match this. So I can say key, I can say, okay, I want only to react on when the W is pressed. I'm going to ignore this. I'm going to ignore the context as well because we don't need it. And here I can just say IO inspect pressed W, no reply state. Yeah. And maybe I'm going to remove this logger because otherwise it's like just too much noise. And actually, let me remove also the logger that prints out the coordinates because we're pretty convinced now that this works. So if I run this, you'll be able to see, okay, now like the thing is there. And if I press W, it actually does that, right? So there's many ways like to handle user input. I think usually like one of the lessons that you learn is that like you don't want the screen to be updated as soon as the user presses something, because maybe they could keep a key pressed, like you could receive, you know, millions of events in theory, and you really want your UI to change sort of synchronously, you know. So one technique to do that is just like to store all the keys that the user has pressed and then do something at fixed intervals. So the easy way to do that in Elixir is just to store them. So I'm going to create a new map called press keys. It's going to be empty. And I'm going to create a new timer with the same sort of interval as the other one, but just going to call it animate paddle, right? And here I'm going to handle it in the same exact way. So actually, let me just copy this. There's nothing to copy. Handle info animate paddle state. And here, basically, I can try to do something and then animate the paddle, right? So as you can see, like these things like sort of like work at different times. Like we are always open to receiving keystrokes, but we're only going to do something about them at fixed intervals. So the way to do that is, for example, here I can just do a new keys will be map put state press keys W true, and here I'm going to change it and do press keys new keys, right? So this is like quite like stateless, like we're not really doing anything, we're just storing the keys that the user has pressed. And here instead we can do something like if map has key state pressed keys W, then we can do something else, we can do something else. So maybe here this is a good candidate, say new graph, right? Like we want to decide if we want to change how the game looks or not. So actually here, let me just do graph, new graph, and just push the new graph. And Scenic will be smart enough that if it sees that it's exactly the same graph, like you won't really do anything. Okay, there's some failures. I think that's, oh, I think I'm just not used to writing Elixir every day. Okay, that's better. So here, if the user hasn't pressed anything, I'm just going to return the existing graph, right? And instead, if the user has changed something, then we want to move the paddle. So I'm going just to make it look a bit nicer by just saying, creating another small function called move paddle up. And here I'm going to pass a graph and going to tell this function which paddle has been moved, right? So if I now move on to implement this function, I have the graph, I have the paddle, and I can do the same thing I did for the ball. So I can grab the coordinates and just autocomplete that. That's it. And instead of grabbing the ball, I'm grabbing the paddle, and here we get the X and Y. And in the case of the paddle, we don't really want to change the X because the paddle is going to remain straight, right? So we just want to change the Y. And when we're moving something up, we're actually reducing the Y of the paddle. So basically our new paddle, like our new Y, is going to be something like Y minus like a magic number. I'm going to call this like paddle velocity. Well, it doesn't really matter. Paddle velocity, let's say 12, yeah. And basically then we just need to do the same dance with the graph and changing the graph and pushing the graph. So I'm going to do that. And you can see here, I can just move the paddle, whichever it was. And I can say that the new X is basically the same. So like this is the X and the new Y is this. And no, I actually, I think the way I wire it up, like I can just return this. This should be fine. And this is called graph, not state graph. The only thing is that if the user is moving the paddle all the way to the top, it could go to a negative number, and we don't want that. So I'm just going to add like a little bit of a safeguard so that it never exceeds, never goes below 0. Cool, let's see if this works. You see, it says press W and it goes up and down. So yeah, I still have some time. Like I thought, like when I was looking at this code, it looked a bit weird, especially if you think that eventually we want to handle 4 keys, right, for 2 players. So I spent some time like trying to refactor this like to a nice way, and I came up with this structure, which I think I quite like. So basically, instead of like doing this new if else every time, we can create like this sort of structure. We can create, first of all, the key that we want to operate on, and then we can pass an anonymous function. And this anonymous function, in this case, is going to do exactly just the same, except that it's not going to operate on that, but it's going to operate on an accumulator. And this here, I'm going to end the tuple, right? Cool. So in this way, if I want to handle the down key for the left paddle, I can just do this and do down. And then I can copy this for the player that's going to control the right paddle. And everything is still the same, but right paddle. Okay. And once you've created like this list of tuples with like these keys and these actions that are associated with that, we can just do a reduce over that. We can say, we can start with the original graph, and then we can say, this is the key, this is the function that we want to run, and this is the accumulator. And inside this thing, I can just say, if map has key state pressed keys of key. So in this way, we're detecting if someone has actually pressed that key. We can run the function on the accumulator. Otherwise, we can just use the original function. And I think I messed something up. It's complaining there's no such function. But I'm not going to spend too much more time implementing this because I'm already out of time. But I just wanted to show you the sort of like more feature complete version. So if I run this version, which is more complete, you see I've also implemented, apart from the fact it's so fast that I lose all the time. So I think that's like a pretty good sign. But I've implemented also like the score and the fact that, for example, when the ball goes out of bounds, the game has a sort of like pause, so that, you know, it gives you like some time to adjust the fact that you just lost and everything. And you can find the code on GitHub. I've just created Pongex. I'm going to post this. I'm not really sure where, probably on Hoover. I'll figure out a way. But yeah, thank you for listening. And let me go through the questions if there are any. I'm not sure how to see the questions. Stop my sharing there. How do I look at the questions? Oh my gosh. I'm going to try to look on the website. How would you refactor the current life? Yeah. So definitely, like one of the first things I would do is to separate the logic that controls the actual data structure of the game, as opposed to the details that you have to use to get Scenic to work. I feel like this is like a trap, and I feel it's also like a trap, like in Gen servers, that sometimes you create you really tightly couple your business logic with the details of how Gen server works. And that's like one of the first things I would do to separate those things. Yeah. And I think like even when you're building a larger game, maybe it's useful to have different scenes. Like it's quite easy to switch between scenes in Scenic, well, as the name implies. But right now I've just basically smooched everything together. And instead, like in a proper game, probably, you know, like there will be like a waiting screen for when you're not ready to play, then you press start and the game starts. And then when the game ends, maybe there's a celebratory screen where you display, you know, who has won and who has lost and everything. I'm not sure if there's, oh, cool. I think that's all. I've run, oh no, there's also other, what would an ideal development environment for Scenic look like? I feel like that's the part which I'm a bit unhappy with, like that there's no live reload mechanism in Scenic. In the past, I've created some ugly script that fetches the process PID of Scenic and just kills the whole supervision tree, and somehow it works, but it's not very pretty. I feel like that should be like more like a part of the library to handle better this like live reloading mechanism, especially when you're developing. It's like otherwise, like it's a lot of control C's. And the last question was, shouldn't we remove the keys? I think I do, because otherwise the thing would be looping a lot. Cool. I think I'm very much out of time. So thank you all for coming.
I just want to say thank you, Ju. I mean, we all know how tricky it is to live code, and this was just a tour de force. I mean, fantastic. Just a big hand. I mean, virtual or real. Truly fantastic, and just showing the beauty and power of Elixir combined with Scenic. I mean, it's just awesome. So thank you so much